Welcome to lesson 34 about other integrations techniques. We are going to study integration by parts and some trigonometric integration. Let's go to practice these problems. There are 30 problems we are going to practice. Let's go ahead. Now the first problem is to use integration by parts. Remember that when you make the derivative of the product of two functions, the derivative of u by v is v by u prime plus u by v prime. If you rearrange this equation, you will have u by v prime equal u by v everything prime minus v by u prime. Now, if in this equation you make the integral of this equation at both sides of the equation, you will find that the integral of u by d dv, it would be equal u by v minus the integral of v by d du. And this is the equation that we would use for integration by parts. So in this problem they say use u equal x. So the u is here, this is the u. And use d dv equals sine 3x v dx. This is d dv. d dv is sine 3x d dx. So this is the u and this is the d dv. u by d dv. What it say integration by parts? Integration by parts say that u by d dv, the integral of u by d dv. What is the integral of u by d dv? The integral of u by d dv is u by v minus the integral of v by d du. So I start with the u equal x. If u is equal x, d du is equal d dx, because d du v du is the derivative, d du is the derivative of u respect to the x by d dx. If u is equal x, the derivative of u respect to the x is equal 1. 1 by d dx, so d du is d dx. If d dv is sine of 3x d dx, who is v? V is the function whose derivative is sine 3x. So v is minus 1/3 cosine of 3x. So now I have all the data to plug in this equation for integration by parts. U, x, d dv sine of 3x equal u, x, v. V is minus 1/3 cosine of 3x, minus 1/3 cosine of 3x, minus the integral of v, who is v, minus 1/3 cosine of 3x, minus 1/3 cosine of 3x by d du, d du, d dx. So this is the equation. And when you use integration by parts, the purpose is to end with an integral in the right side of the equation that is easy to solve, or at least is easier to solve than this original integral. So we have converted the initial integral into a function, a part of the antiderivative of this function, minus or plus the integral of the antiderivative of another function. What is the antiderivative of 1/3 cosine of 3x? Oh, this is easy, it's 1/3 sine of 3x. The antiderivative of cosine of 3x is 1/3 sine of 3x. With this 1/3 will go here, minus will go plus, and so we already found. The integral of u by d dv, x sine 3x d dx, is minus x 1/3 cosine of 3x plus 1 divided by 9 sine of 3x. If you want to write it in this way, factor common 1 divided by 3, 1/3, so it would be And this is the final solution, plus c, of course. Let's go to the next problem. Next problem, we do the same thing. We use integration by parts to solve the integral to find the antiderivative of x cubed natural log of x. And the problem is say use u as natural log of x and use dv like x cubed ddx. So u by ddv is x cubed ddx. So what it say our equation? Our equation says that the integral of u by ddv is u by v minus the integral of v by ddu. So let's go to write it. U is natural log of x. V dv is x cubed ddx. So if u is natural log of x, who is ddu? Ddu is the derivative of u respect to the x by ddx. What is the derivative of u respect to the x? Is 1 divided by x by ddx. So this is ddu. And if ddv is x to the third power, v is the function whose derivative is x raised to the 3, so it's x to the 4 divided by 4 is v. Now we plug our data in this equation. U by ddv, natural log of x by ddv, x cubed ddx, equal. U by v, u natural log of x, by v is x4 divided by 4, minus the integral of v by ddu. V is x4 divided by 4. By ddu is 1 divided by x ddx. So 1x will cancel with x4. It will appear x cubed divided by 4. So now we have obtained an integral that is much more easier to solve. Indeed, it's so easy that it will be solved immediately. So it will be 1/4, the 4 will go here, 1/4, natural log of x, x4, minus 1/4, x4 divided by 4. If you take common factor to x4, 1/4 x4, common factor will be natural log of x minus 1/4 plus c. And this is the final solution. If you believe me, perfect. If you don't believe me, you can make the derivative, you can always make the derivative of this function of the antiderivative. If you make the derivative of the antiderivative, you will obtain x cubed natural log of x. You can do it. Okay, next problem. Next problem is more of the same. Is use the same equation, u by v minus the integral of v by ddu. So the integral of u by ddv, it would be u by v minus the integral of v by ddu. So in this problem, they don't say who is u and who is ddv. So we have to choose. So we choose u equal x and ddv the rest of the equation. So u by ddv, u is x, ddv is e to the minus 4x ddx. Who is v? V is the function whose derivative will be e minus 4x, so it will be minus 1/4 e minus 4x. So this is v, and if u is x, ddu is ddx. Apply your equation. U by ddv equal u by v minus v by ddu minus the integral of v by ddu. U, x, ddv, e minus 4x, u by v, so u x v minus 1/4 e to the minus 4x. So this is u by v minus the integral of v is minus 1/4 e minus 4x by ddu. V by ddu. Ddu is ddx. So now we have an easier integral to solve. And this integral is straightforward to solve. It will be minus 1/4 e to the minus 4x. This is the integral of e minus 4x. The integral of e minus 4x is minus 1/4 e to the minus 4x. And the problem is solved. So now you can take common factor e minus 4x, and the solution will be written in this way, plus c. And this is the final solution. Okay, let's go to the next problem. Next problem say, again, the same thing. I'm not going to solve it. I'm going to solve it. It's already solved. U by v minus v by d du. So you choose u equal x. You choose d dv equal cosine of x d dx. Who is v? Sine of x. Who is d du? d dx. You apply your equation and you will find u by v, x sine of x, minus v d du. V sine of x, v d du, v d du, v d du, v d d sine of x d dx, sine of x d dx, and we have now a more easy integral to solve. The integral of sine of x is cosine of x minus cosine of x. If you plug in minus cosine of x, you will obtain as the final result that the integral of x cosine of x d dx is x sine of x plus cosine of x plus c. And the problem is solved. Now let's go to the next problem. What is the next problem? The next problem is find the arctangent of x d dx. If you see this integral, you will say, I have no idea how to solve. No idea. But look at this. If you use integration by parts, you can perform this integral. U is equal arctangent of x. d dv is d dx. So the equation that I'm using is that the integral of u by d dv is u by v minus the integral of v by d du. Let's go to plugging numbers. U is arctangent of x. V du is the derivative of u respect to dx. The derivative of arctangent of x is 1 divided by 1 plus x squared by d dx. So d du is this expression. And d dv we choose to be d dx. Who is v? V is x. Apply your equation, u by v minus the integral of v by d du, and you will see that you find an equation, an integral, in the right side of the equation that is easier to solve. The equation that is v by d du. V is x, d du is 1 divided by 1 plus x squared d dx. And this equation is a natural log. It's the natural log of 1 plus x squared because the derivative of this is 1 divided by 1 plus x squared multiplied by 2x. So because there appear only an x, so I will put it 1/2. So the solution to the integral of arctangent of x d dx is this solution. And if you don't believe, you can do the derivative of this function, of this one, and you will find arctangent of x. Do it. Okay, next problem. Next problem say, again, to apply the same equation, the same trick to find antiderivative, that is integration by part. U by d dv equal the integral of u by d dv is u by v minus the integral of v by d du. What we will choose? We will choose u to be natural log of 2x. So d du is 1 divided by the function 2x by the derivative of the function 2. So d du will be 1 divided by x d dx. Perfect. Who is d dv? d dv is 1 divided by x squared d dx. 1 divided by x squared, so we have choose this integral to be 1 divided by x squared natural log of 2x d dx. So 1 divided by x squared d dx is d dv. And this is u. Okay, so we plugging numbers again on my equation u by v. U by v, natural log of x, u by v. V is the integral of d dv, and v is the integral of 1 divided by x squared ddx, and it's x minus 2, and x minus 2 is minus x minus 1, so it's minus 1 divided by x is v. So it's u, natural log of x, by v. V is minus 1 divided by x, u by v, minus the integral of v, v is minus 1 divided by x, by d du. V du is here, d du is 1 divided by x ddx. Doing the integral, it will appear an integral that is much more easy to solve than the original integral. So the integral of x minus 2 is minus 1 divided by x. So the final solution that we have is that the integral of natural log of x, the integral of natural log of 2x, 1 divided by x squared ddx is equal minus 1 divided by x natural log of x plus the integral of 1 divided by x squared, which is minus 1 divided by x squared by x. So taking common factor of 1 divided by minus 1 divided by x, minus 1 divided by, but natural log of 2x plus 1, plus c, this is the final result for the integral that we are solving. And again, you can make the derivative of this function, and you can find this function here, natural log of 2x, 1 divided by x squared. Let's go to the next problem. The next problem is again the same thing. This problem is a little bit more sophisticated, but it's not so bad. Use substitution and integration by parts to solve this equation, to solve sine of a square root of x ddx. So the first thing that we do is we use substitution to write omega equal square root of x. If we define omega to be x 1/2, is because omega squared is x. So 2 omega dd omega is ddx. 2 omega dd omega is ddx. So the equation that we have is 2 omega dd omega equal ddx. And the other equation that we have is that omega squared equal x. So let's go to plugging to make substitution first, and later on to make integration by parts. So it will be the integral of sine of a square root of x ddx will be the integral of sine omega ddx, but ddx is 2 times omega dd omega. So it will be sine omega by ddx to omega dd omega. And now I will have to solve the integral of 2 times omega sine omega dd omega. How we will solve this integral? We will use integration by parts. Because omega maybe is confusing, let's go to call it x prime instead of omega. Omega is x prime, so the integral that we have to solve is 2x prime sine x prime ddx prime. So I have changed the omega by x prime to make it to recognize better. So now I have an integral to solve, that is the integral of x prime sine of x prime ddx prime, and there is a 2 here that I cannot forget, these 2. Okay, so let's go to solve this part. So we use integration by parts. When we use integration by parts, we choose u to be x prime and v dv to be sine of x prime ddx prime. V dv is sine of x prime ddx prime. If u is prime, ddu is ddx prime, and v is minus cosine of x prime. We apply our equation for integration by parts, and we obtain u by v, u x prime by v minus cosine of x prime, minus the integral of v minus cosine of x prime by ddu, ddx prime. And now this equation is easy to solve. in terms of x prime. Remember that x prime is omega, and omega is x squared. Omega is omega squared is x, and omega squared is x. Okay, so we solve in terms of x prime. When we solve this integral in terms of x prime, this is sine of x prime. So the integral will be minus x prime cosine of x prime plus sine of x prime. Now because x prime is omega, and omega is equal to x squared, we change the x prime by x squared. And now omega, sorry, I made a mistake again. Omega is a square root of x. So x prime is a square root of x. And now we change the x prime by his value, a square root of x. So wherever I see x prime, I will put a square root of x. So the final solution will be minus x prime, square root of x, cosine of x prime, cosine of square root of x, plus sine of x prime, sine of x square root of x. And this is the final solution, plus c. If you don't believe me again, you can do the derivative, and the derivative of this function should be sine of a square root of x. Try. Let's go to the next problem. Now, on this problem, we have a integral that involves the product of two functions that are trigonometric functions, are sine and cosine. And the product is sine 7 means sine of 2x7, sine 2x7 means this. In mathematics, they write like this, sine 7x. But indeed, what it means is sine, the I, sine x 7, which is sine x by sine x 7 times. You multiply 7 times sine of x. Okay, sine of x 7 times, so this is sine x 7, and in mathematics they write like this, sine 7x. But this is what it means, and you cannot be confused. So to solve this integral, we don't use integration by parts, we use substitution. We name u equals sine of 2x. Why we name u equals sine of 2x? Because the derivative of u, or the derivative of sine of 2x, is sitting down here, is cosine of 2x. So the derivative of u respect to the x is 2 cosine of 2x. Or in other words, d du is 2 cosine 2x ddx. So the problem is almost solved. Sine 7 2x is u7. And cosine 2x is d du divided by 2. d du divided by 2. Cosine 2x ddx is d du divided by 2. And now the problem is solved, because u7 d du is u8 divided by 8. So we now The problem is not solved yet. Now, because we have named u to be sine of 2x, we replace the u by sine of 2x, and it will be sine 2x to the 8th power divided by 2 multiplied by 8, 16, plus c. And this is the final solution. So substitution will work in this problem. Go to the next problem. The next problem says find the integral of sine cube cosine square of x d dx. Now, can we use substitution here? It's not so easy because u is sine of x. If you use u sine of x, d du will be cosine of x d dx, but here it appears cosine square of x d dx. So we need to do some manipulations to this equation to find the integral. So this is the manipulation that we do to make to appear the integral in an easy way. Sine cube is sine squared by multiplied by sine. We decompose the sine cube into sine squared multiplied by sine, cosine square of x d dx. Now, we replace sine square of x by a trigonometric identity. The trigonometric identity is that sine square of x is 1 minus cosine square of x. What we have done is that now we have converted, if you multiply this by this, it would appear cosine square of x sine of x d dx, and cosine 4 of x sine of x d dx, it will appear 2 integral. But now it's clear that we can use substitution if we name u like cosine of x. If we name u cosine of x, d du, which is sine of x d dx, d du will be minus sine of x d dx will appear here. So now we have start with a difficult integral. Wherever you find trigonometric equation and it appear an even and odd power, it will be easy to find. When it appear two even powers, this is more difficult. With 2 even powers, it's more difficult. But this is easy because you can convert it, like we have done, into an equation where you can use substitution. So let's go to use substitution now. Now we name u equal cosine of x. So, and d du will be sine of x d dx minus sine of x d dx. So u is cosine of x. d du is minus sine of x d dx. So the integral will be u squared minus sine of x d dx is minus d du minus the integral of u is cosine of x, u to the 4, u4. Sine of x d dx is d du divided by 2. d du is d du. With this minus, it will be minus, it will appear a plus. So it will be minus u cubed divided by 3, which is the first integral, plus u5 divided by 5. Now make it, doing the changing from our word of u to our word of x. U is cosine of x, will be cosine q of x divided by 3, plus cosine 5 of x divided by 5 plus c. And this is the final result. Let's go to do the next one. The next one is like this. Is find the integral of sine secant square of x tangent of x. So we choose, the first things that we do is we do almost the same trick that we did before. Instead of writing secant square, we write secant by secant tangent. Oh, but secant tangent is the derivative of secant x of x. The derivative of secant x is secant tangent. So I choose u to be secant of x, and d du is secant of x, tangent of x immediately. If u is secant of x, ddu is secant x, tangent of x, ddx. So the integral that we have here is u by ddu. U by ddu. What is the integral of u by ddu? Is u squared divided by 2. The problem is not solved yet. Who is u? U is secant x. So it will be secant x squared divided by 2 plus c. And the problem is solved. There is another way to do it, and you may be surprised to obtain what it will be a different solution. And the way to solve it is like this. I can choose u to be tangent of x. What is the derivative of tangent of x? Is secant square of x. So I can choose u to be tangent of x. And ddu will be secant square of x ddx. ddu will be secant square of x ddx. Now I will use substitution. U by ddu. Remember that u is tangent of x now in this new way to do it. It will be u squared divided by 2 plus c. But u is tangent of x, so it will be tangent square of x divided by 2 plus c. And now this is our new solution. So you would say, is tangent squared divided by 2 plus c, let's go to put c prime, equal to secant square of x divided by 2? It looks different. Secant square is 1 divided by cosine square of x. And tangent square of x is sine square divided by cosine square. So you may be surprised and say, wow, this is two different solutions. Well, remember this. Sine square of x plus cosine square of x is equal 1. So if you divide the fundamental trigonometry identity by cosine square of x, sine square of x divided by cosine square of x will be tangent square. And cosine square of x divided by sine square of x, it will be divided by cosine square of x will be 1. And 1 divided by cosine square of x, it would be secant square of x. So this will be equal to tangent square of x, which is secant square of x minus 1 divided by 2 plus c prime. So it will be secant square of x divided by 2 minus 1 divided by 2 plus c prime. So this is c. So it's the same solution. It looks different, but it is secant square plus secant square of x divided by 2 plus c is the same solution that this one. Maybe is if you use your calculator, your graphing utility, and you plug in these two equations, tangent square of x divided by 2, and you plug in secant square of x divided by 2, you would see that they are very, very similar. Maybe one, it will appear translated to the right respect to the other, but the solution is the same. Okay, let's go to the next integration of trigonometric integration. Tangent square of x secant 4 of x ddx. It looks difficult, but there is a trick. You decompose, you use a trigonometric identity to solve this integral. So you will write tangent square of x. Instead of secant 4, you will write secant square by secant square. You have not done anything. Now you use the fundamental trigonometry identity that say that secant square of x is 1 plus tangent square of x multiplied by secant square of x. What is the trick here? The trick here is that when everything is based on tangent of x, like this thing, the derivative of tangent of x is secant square of x ddx. So If I name u to be tangent of x, d du will appear here. So I multiply this by this. So if I multiply this by this and use the distributive property, it will appear tangent square of x, secant square of x, tangent square of x, secant square of x, plus tangent 4 of x, secant square of x ddx. And now I will use u to be tangent of x. If u is tangent of x, and I use substitution, it will appear ddu here. Secant square of x ddx will be ddu. So the integral is almost solved. It will be u squared tangent square of x, u squared by ddu. ddu is secant square of x ddx, u by ddu. And here will be u4 ddu. What is the integral? u3 divided by 3, u5 divided by 5. Who is u? Tangent of x. Tangent cube of x ddx plus tangent 5 of x divided by 5 plus c. This is the solution. Let's go to the next one. The next one is evaluate cosine square of x ddx. To evaluate this integral, you need a pre-calculus to remember trigonometric relation, and the trigonometric relation that you need to remember is that this is not calculus for sure. This is some trigonometric relation that say that cosine square of x is 1/2 1 plus cosine of the double of the angle, cosine of 2x. So you use this equality and you substitute cosine square of x by 1/2 1 plus cosine of 2x, you can find immediately the integral because it will appear very easy integrals to solve. 1 by ddx, the integral is x. Cosine of 2x, the integral is sine of 2x divided by 2, and this is the result. So sometimes you need to, for even powers, you need to use this identity of that say that cosine of square of x is 1/2 1 plus cosine of 2x, and sine square of x is 1/2 1 minus cosine of 2x. And if you sum this with this, or this with this, it should be 1, because sine square of x plus cosine square of x is 1. You can sum it, you can see that the sum, there is a positive sign here and a negative sign here. So it will be 1/2 plus 1/2, it will be 1. So if the integral that they ask you is sine square of x ddx, you will use this relation to solve the integral. Okay, now let's go to the last one. Which integral is easier to find, to solve? Tangent 400 of x secant square of x ddx of tangent 400 of x secant x ddx. Oh, which one is easier? Well, if I name u to be tangent of x, ddu will be secant square of x, so the first one is much more easy to solve. And what is the integral of this one? Well, it will be the integral of tangent 400 of x secant square of x ddx will be equal u, the integral of u 400 by ddu. So it will be u 401 divided by 401. Oh, but who is u? U is tangent of x, so it will be tangent x 401 divided by 401 plus c, and this is the solution. So the problem, the 13th problem is solved. I hope it will be helpful for you. You can review each one. I try to do it as faster as I can. Good luck.